So the speed of diffusion, I'm going to show you there, relative atomic mass, so due to random movement, any evaporated particle will move randomly, but particles will tend towards an area of low concentration of their particles due to diffusion. That's where they meet, because there's a low concentration of H3 and a high concentration of hydrochloric acid. The concentration of, yeah, they'll meet somewhere there. So yeah, the arrows represent net movement of particles, and the dot with the arrows on is random movement of particles, and the little squiggles is where the particles will meet from both chemicals. Evaporated particles will move randomly, but will tend towards an area of low concentration due to fusion, but hydrochloric acid particles are twice as heavy as ammonia particles, and it would take more energy for the hydrochloric acid particles to move. So, because kinetic energy is equal to half mv squared, that means that the it take more kinetic energy for the hydrochloric acid to move. So we can use crude oil for fuel, but there's long hydrocarbon molecules in crude oil and they're not very useful for fuels. We can make larger hydrocarbon molecules into more useful substances. We break them down to small molecules through cracking. That's it. So, yeah, so a refinery, maybe that's probably not the best diagram to use. These are incomplete. I'll get something up, so bear with me. Useless sheets. Useless crap. Sorry, these are all useless. Right. On to physics. Okay, so acceleration practical cylinder down a ramp. Place a block of wood under the ramp and record the height. This is a constant throughout the experiment. Mark on the ramp with a pencil a start line. Every 10 cm from the start line to 10 cm mark intervals on the ramp. Place cylinder on a straight line and simultaneously start stop clock and release the cylinder. Time how long it takes to travel 10 cm, repeats 3 times and calculate the mean. Repeat the experiment for every interval until 100 cm, releasing the cylinder. From the start every time. Record all results in a table and plot and draw the distance time graph of all the mean data. That's what it will look like. There we go. So, we don't really need to know these, because we already know them. So pendulum experiment. The graph is a straight line passing through the origin. Therefore we can conclude that the length is directly proportional to the time squared. If we got a straight line but it does not quite go through the origin, we have a systematic error, we have to square time period because time is equal to 2 pi square root of length over gravitational Newtonian force. Density. The density of substance is mass per unit volume. Find density of a regular shape. Measure the length, width, height using a ruler. Volume is length times width times height. Measure mass using a balance. Calculate density using the equation. Water is 1 gram per centimetre cubed. Find the volume of a regular object. Okay, so the it may not be accurate because the object as to water, some may splash out or spill out of the Eureka can or measuring cylinder. Measuring cylinder may only have markers on a scale of 1 centimetre cubed, which means volume can only be read to 0.5 centimetre cubed. The ruler used when calculating regular density can measure to 1 millimetre. So just times by 1,000 to convert grams centimetre cubed to metres cubed. For small objects, so find the density of a regular solid, find the mass using a balance, find the volume by fill a measuring cylinder with water and record the volume, then add the object and record new volume. So volume is read from the bottom of the meniscus. Volume object is V2 minus V1. Calculate density using density of mass over volume, or the Eureka can. Find the mass using a balance. Find the volume using a displacement or Eureka can. Fill a Eureka can with water. Place the object in the can and collect the displaced water in a measuring cylinder. Volume of water displaced is equal to volume of object. And calculate density using mass over volume. Find the density of the liquid, so record the mass of the empty measuring cylinder using a balance. Pour some liquid in the cylinder and record the new mass. Cylinder plus liquid mass. Track the readings, so the new mass minus the empty mass, or M1 minus M2 minus M1. Find the volume by reading off a scale on the measuring cylinder. Density equals mass over volume. One always remember to accurately say mass, not weight. They're two different things. Find density of air. Find the mass of a flask with air in using a balance. Connect the flask to a vacuum pump to remove the air. Clamp the tubing to prevent air re-entering the flask. Find the mass of a flask with empty air, no air, M2. Calculate the mass. And so the first point minus M2, so M1 minus M2. Fill the flask with water and using a measuring cylinder, pour water from the flask into the measuring cylinder. Find the volume of the flask, which equals volume of air, and then rho equals M over V. It's practical of it. There we go. Mass is a measure of how much matter an object is made up of. For a particular object, the mass is the same anywhere in the universe. Mass measured using a balance is measured in kilograms or grams. Weight is the force acting on an object due to a gravitational pull. Weight is measured using a Newton meter. Spring balance and is measured in newtons. In the middle of space, the gravitational field strength due to the Earth or any other planet can be considered negligible, almost zero, so the object is said to be weightless. So W equals mg. Gravitational field strength on Earth is 10 newtons per kilogram. Hang on.